obviously, and it's only 8 people right now hooked up, so the results are pretty even. It looks like the winners are, I've finished app 1 and I've finished app 2, which is awesome. One of you has started it but hasn't yet knocked out app 1, and 2 of you are still in the planning stage, which is better than the wait, there's an exam stage, which I do occasionally get. We are in chapter 9, methods. And a method, just to remind you, is a block of code that we name and that we can invoke then anytime we want by calling its name. So it's a great way to, well, there's several advantages which are actually on the next slide. So let me just hit the next slide. There are benefits to this. The kind of the big picture benefit is modularization, which just means that methods allow us to break a complex task up into smaller tasks. That's one of the ways that we approach complex, large problems, is to start modularizing them, breaking them into smaller steps, and potentially breaking the code into separate modules that different programmers or different teams can work on and then bring back together. So a method potentially gives you a smaller and more manageable chunk of code to work on rather than trying to tackle a much larger composite problem. The other big benefit of modularization is, to some extent, it will stop you from having redundant code, or it will help you not have as much redundant code. And I say that because the most common way people realize they need a method is that they've written some code and it works great, it's been tested, they like it, and then later in their program they need to use that same code again. And then you're faced with this choice, which is, do I just go up and find that code that I already have working and copy and paste it? Because that would work in lots of scenarios. Or do I do something else? So the problem with the copy and pasting, although it seems easy, seems like maybe it's even the easier way to do it. The problem is, once you start doing that, you could end up with several copies of the same code throughout your maybe large complex app. And then what happens when you realize that there's a small bug, or there's something that needs to be tweaked, or there's an additional feature that needs to be added to it? If you've copied and pasted this throughout your code, then you're going to need to go back and look through your code to find everywhere you pasted it and make those same changes, which opens the door for then inconsistent code where there should be consistent code. With a method, you only have the one copy of that code. If you need to update the code inside the method, you update the code inside the method and you're done. And everywhere else in your code where you call the method doesn't need to be altered. So lots of benefits to using methods. These are a way also to control the flow of execution. You call a method, the flow of execution jumps to the code inside the method. And the code inside that method is run, and then the flow of execution returns back to that calling line of code. It is in some ways sort of like an if statement, although instead of obviously using the keyword if, you use the name of the method you want to evoke, and the flow of execution jumps to that code. Method syntax. So the way that you define a method, there is no keyword. In some languages, there's a keyword like function or a keyword like procedure that you type in that tells the computer, okay, now you're declaring a method. Java doesn't do that. The way Java for sure can tell that it's a method is actually when you name it and put parentheses after it. That's the syntax which is restricted to methods. So, but there's several pieces of this puzzle. This first line of code that you write contains a bit of complexity that you'll need to get the hang of, but it's totally doable. This is also called the method signature. So there's 4 important details. There's something called an access modifier, which could be public, private, or protected. So far in this class, we've avoided really discussing in any depth access modifiers. We will come back to them in chapter 10 when it starts to make a bigger difference. It is optional, it does say optional on the slide, but I don't know if I said that. But the access modifier is not required. If you leave it off, it gets what's called default or package level access. Again, we'll talk more about that in chapter 10. There's a required return type, and that can either be the keyword void, which means there's nothing returned, or it can be a valid Java class or data type that the method generates and sends back. There's a required method name, which is a valid Java identifier, so it follows the same rules as all the variable names that you've created. There's parentheses, which enclose an optional parameter list. So the parameter list doesn't have to contain any parameters, but it does have to have the parentheses that surround where the parameter list would go. If you leave off the parentheses, even if they're empty, Java will not see it as a method. It will see it as a variable that you're trying to use, and the syntax then won't work. So a little bit more visually, if you're actually typing it in, this is how this is all laid out. The optional access modifier is first. Again, I don't think we use that today at all. Then there's a return type. Again, the return type is void or a valid data type. There's the parentheses, which are required, and then inside the parentheses is the optional parameter list. There's then open and close curly braces, which surround the body of the method. So everything in between the open curly brace and before the closed curly brace is the method body. That is one or more Java statements that do the work that you need done when the method's called. Methods can be quite short. Certainly many of the examples today are very short, 1 line or 2 lines, or they can be really quite long. All right, so this is a common theme in learning Java, is that maybe without knowing it, you've already been using methods. The main method is a method. Every single app that we've written has a main method. You know it's a method, well, at least 2 ways. One is because we call it the main method, which should be a decent clue. And then if you look at it now through the lens of the syntax we just talked about, you see the keyword, the access modifier public, something adjacent to it, which also modifies the scope. You see the keyword void. You see main, which is a valid valid Java identifier. You see the parentheses. Inside the parentheses, you see a variable declared, and then you see the open and closed curly brace. So looking at it now through the lens of what we just talked about, clearly main is a method. The second method I show you there from this first Hello World app is the constructor, and it's a little different, and we'll talk more about that in a minute, but it is a method, and you may have also realized that it's a method because we typically call it the constructor method. So you've absolutely used methods, written methods, taken advantage of methods. Another example would be all of the event handlers that you've coded. Even if you let Eclipse write the actionPerformed method itself, you supplied all the code that was inside of it. So you have actually used methods quite a bit, maybe without fully realizing it or appreciate it. So it's not an entirely new concept to you, whether you fully realize that or not. So the constructor, I said we'd talk a little bit more about the constructor. It obviously violates the syntax that we just talked about, right? Let me hop back to the syntax. This is the syntax. Optional access modifier or modifiers, a return type, void or a data type, a method name, the parentheses with an optional parameter list. So jumping back to the constructor, hello, well, there's no access modifier, but that was optional. But importantly, there's no return type. The return type is required, and yet there's no return type. So what's the deal? Well, the deal is constructors are a special case. It seems like every time you say these are the rules, then you need to think through, well, what violates the rules? Because Java does do that. It tries to be very consistent about its rules, that each rule is consistent with the other rules, and then also that the rules are applied consistently. But then through error or intentional, omission or deviation, they do occasionally violate their own rules. And then the constructor method is one of the most obvious examples of that. So there's no return type. If you wanted to think of the return type would be the app itself. But for whatever reason, we don't put that, and we don't put any other sort of special return type. Other than that, it does meet the other requirements, that there is a valid identifier that happens to match the class name. The other way it violates it, which I forgot to mention earlier, is that method names by convention start with a lowercase letter. So main starts with a lowercase letter. If you think back to, for instance, actionPerformed, the A in actionPerformed is lowercase, and so on. And yet the constructor method is capitalized. If you go back again, you see it's hello capitalized, and that's because, again, it violates the rule. And it has its own rule, which is the name of the constructor method has to match the name of the class exactly. So if the name of the class is capital H hello, then the constructor has to be capital H hello. If you make it something else, if you don't capitalize the H, for example, then it's not a constructor method, and then you'll get an error because you will have to then follow the rules. And just as a reminder, in terms of the constructor method is executed one time when the app starts. So we have been using the constructor method to set up the UI, for the most part, to set up our UI in the app, to manage the layouts, to manage panels, to put stuff on panels, to put panels in locations in the JFrame, to create our, our graphical windowed apps. We'll talk more about constructors in chapter 10. All right. So there's 4 types of methods. Essentially, there's 2 decisions that you have to make when thinking about writing your own method. One of them is, does my method accept parameters or not? Is it going to need data passed to it to do its work? Some methods need data passed to them, others don't need data passed to them. So that's the question of the parameters. And that's, you can see on the left-hand side of this table, the 2 options are does not accept parameters or accepts parameters. There aren't any other choices. Same thing with the return type. You want to ask yourself, does my method calculate something or produce some result that I need to send back to the calling line of code? If so, it does return something, and you need to specify what it returns in terms of a data type. You could say, for instance, if it does something with strings to build maybe a longer string for use in a report, then if it returns that string, then the return type is string. If it just does something and doesn't produce a result that has to be returned, that's called a void method. They're just different design decisions that you have to make. And you have to have pretty well in your head when you start typing the method, obviously. Otherwise, you're not going to know whether you type void or something else. But so I've created this 2x2 grid with these numbers. And then I'm going to use these numbers. If you've already scanned through the chapter, you'll see I use these numbers to identify the methods that are used in the chapter. So method type 1 doesn't return a result, so it's void, as is method type 3. Those are both void methods. But method type 1 doesn't take any parameters, and method type 3 takes parameters. And then the non-void methods, 2 and 4 are the non-void methods, so they will have a data type in place of the keyword void, and then cell 2 does not accept parameters like cell 1, and cell 4 accepts parameters like cell 3. So the very next slide actually gives you these tiny little methods. These are about the smallest things I thought I could type and fit in a Keynote slide and keep the font size large enough that you could actually read it. And this is actually in an app in the chapter resources called SimpleOneOfEach if you wanna play with these. Anyway, let's look at them really quickly and just point out some stuff. Well, first off, obviously see that this is the exact same table with the same numbers. I've just shoved the numbers over to the side to make room for some code. The code in each of these 4 cells is a valid method. And I've even named them method 1, method 2, method 3, method 4, where the methods also match, the numbers of the methods match the cells, just trying to help you keep stuff as straight as possible. Looking at, for instance, the parameter issue first. The top row is does not accept parameters, the bottom row is accepts parameters. In the top row you see the parentheses after the method names, method 1 and method 2, but the parentheses are empty because they don't take parameters. In the bottom row, methods 3 and 4, you still see the parentheses, but now they're not empty. In method 3, it takes a string, and the string parameter is named name, so that inside the body of the method, you can use that parameter to access whatever data was sent to it. And then method 4 takes 2 parameters. So here's an example of taking more than one parameter. The syntax is to use a comma to separate multiple parameters. Each parameter has to be declared with a data type and a name. So in this case, I call them string param1 and string param2. And then we can use those identifiers, param1 and param2, inside the body of method 4 to do stuff with the data that's passed to it. So that's an example of all 4 of the method types. They're very small examples. The goal is to show you the syntax, valid syntax, not necessarily to give you any great ideas for methods that you might make. Okay, so the next slide is going to talk about how we call these. That is, if we've typed these in and put them in our code, then how do we use them? Obviously, you want to use them because that's why you spent the time making them. And luckily, using methods is the easy part. I mean, if there's a hard part, it's designing the method and figuring out these things that we just talked about and then getting the syntax right. Using methods tends to be really easy. So you call a method or invoke a method by using its name and then passing it any parameter data necessary inside of the parentheses. The key thing again, which I'm repeating myself, but I will do it a couple times today, is just to remind you that you still have to have the parentheses. When you put parentheses after the method name, that confirms to Java that you're calling a method of that name. If you leave the parentheses off, it assumes that you're trying to do something with a variable that uses that identifier, which then will cause syntax errors. Likewise, if you were to add parentheses after some variable that you're using in code that's already working, that would break it because that would then make the compiler think that you were trying to call a method that didn't exist. So parentheses are required if it's a method and should not be there if there is not a method. The other thing about void and non-void, these are called differently. So non-void methods are inserted into statements as part of an expression. And then void methods are complete statements on their own. And that may sound more complex than it really is, and obviously the next slide has examples. But the way you call any method is defined right in the method signature. If you're not sure how to call a particular method, you could just scan down to the method signature and see, okay, what's the name? Does it take parameters? What are the data types of the parameters? And what order do they have to be in? The IDEs will try to assist you here. When you start to call a method, autocomplete will show you the parameters that are required, and you can enter data and use tab to or return to move through the data items. So the IDEs will try to help you out in terms of just using the method correctly, not necessarily in terms of writing it or making sure it's a good method. Okay, so looking at these four methods again, one more time, let's look at how you call them. So again, there's these four methods, 1, 2, 3, 4. They're representative of each of the four cells in the table, which you can flip back to if you want a refresher, but let's just look at it from the beginning. So method 1, all it does is system.println the word hi to the console. In other words, it's a void method. It doesn't calculate any result. It doesn't return any data. It just does something. So there are some conventions in terms of naming methods that you might want to think about that I have not followed here because I wanted these to be method 1, method 2, method 3, method 4. But there are some conventions. So for methods that are void, that is methods that do something but don't calculate some result to return, these are often either called set methods. So you're using the method to set some variable or set something up in some way. These are also frequently called do methods, things like, do update or do page turn or whatever might make sense. The word do makes you think that this method is a method that does something rather than a method that calculates something. And then the methods that return data are frequently called get methods. So getBalance or getAverage. I haven't followed that naming convention here, but I want to get that in your head so that when we get to slightly more realistic examples, you'll start to see hopefully the pattern. It's not a requirement. Java doesn't have any requirements at all about how you name methods, except that they have to be valid identifiers. Beyond that, it's entirely up to you and or your programming team to think about how do I want to name these methods, and is there a way I can name them that will distinguish easily between the methods that are either void or non-void, so that it makes more sense when I call it and when I'm typing in the syntax what I'm doing. Okay, so method 1 is what you would call a do method. All it does is put the word hi at the console. So if you wanted to name it more descriptively, you might say something like do hi. And that would sort of imply that all it does is do something involving a greeting. Method 2 is a non-void method. It returns a string. It actually returns the word there. So method 2 in and of itself is not a complete statement. Method 2, when you call it, produces a result. And then you have to use that result in the expression. Another way to think of it is, since method 2 returns a string, you could actually in your mind just take that, I'm in the second row there, system.println method 2, you take out that method to call and just put the word there in there. That's what the result of calling method 2 is it is replaced by the return value, which is the word there. So I need to do something with that string, and one thing I could do is system.println it. And if you haven't figured out what these 4 things do, obviously when run in sequence, they say, hi there, John Arg. So nothing super fancy. Method 3 takes a parameter. Method 3 is a void method. You can certainly it implies that it's a void method if you don't remember what 3 is, because it exists there as an entire statement. Line 3 is simply a call to method 3. So method 3 is what you might call a do method. If you named it more descriptively, it might be set name. That would probably be a more descriptive name that would tell you that it was a do or a set kind of style method. It takes one parameter, which is a string, so I've passed it the string John. And what it does inside of method 3 is it just displays that at the console. And then method 4 is another non-void method. It returns a string. So like method 2, it needs to be incorporated into an expression to be able to do anything in your code. The method itself just concatenates the 2 string parameters that are sent. So I send it the 2 strings arg and exclamation point, which it concatenates together and then returns the result, which is arg exclamation point. So if these were run in order, we would get hi there, John Arg. Not the most useful methods. Certainly, again, they're created just to give you a very simple initial example of a type of method in each of these 4 cells. Obviously, you can also play around with them. So what I do next in class is we stop and we do an activity, which is just to take those 4 methods and put them in an app and then customize them to, say something more unique to you. So let's switch over to Eclipse. So I'm going to switch over to screen sharing and then show you my Eclipse screen. But literally all I'm going to do is I'm going to show you the SimpleOneOfEach app, or I'll grab the methods out of it and then we'll play with them a little bit. So if you want to be able to follow along, see if you can grab the SimpleOneOfEach example out of the chapter resources. You should see Eclipse. Okay, so what I've opened up here is SimpleOneOfEach. This is what you would download if you're taking that step. I'm just going to grab these 4 methods and copy them, and I'm going to create a new version of this, and just we'll type some stuff in and see what happens. So I'm going to call it SimpleOneOfEachDemo. I do want a main method, and I'm going to paste these methods in here. And so that may bring up the first question for you is, well, where do I put these methods, right? The rule is that they have to be inside of a class and outside of any other method. You cannot put methods within methods in Java. In other words, there's no nesting methods, which if you're used to doing that, it can be a useful technique. Certainly we made use of it, or I made use of it in some of the more complex Lua and mobile development apps. Java just doesn't do it. The order makes no difference. I could have pasted them before the main method, after the main method. I could split them up and put half of them before the main method and half of them after the main method. It does not matter. The order is irrelevant because they aren't called by themselves. They're just declared. They're called when you as the programmer call them, or if they're special methods like the constructor method or event handling methods, then they'll be called when appropriate. Okay, so I need to do a few things to actually make this runnable. All we're doing is using the console here, so I don't need to extend JFrame. there's no window GUI. I could use a constructor certainly for consistency. So we'll create an app of this type, and then I'll supply the constructor. So now I actually have a complete app. It doesn't do anything except create a copy of itself that doesn't do anything. So to do anything, we'll add some code here into SimpleOneOfEach. So if you're following along, then here's where we call the methods. all we've done to this point is define or declare the methods. So method 1, method 2, method 3, method 4 are ready to go. For some reason I've renamed method 4 add punctuation. I don't know if that's in the version you download or not, but I'm going to change it back to method 4. For consistency, I'm assuming I changed it last time I taught this to show you what happens when you change a method name, and I just forgot to change it back. So this is now method 1, method 2, method 3, method 4, like you should get in the download. Okay, let's just do them in order. So to call method 1, I'm going to look at method 1. It's a void method, so I don't need to do anything but literally just name the method, put the parentheses. The parentheses are there, but they're empty. They're empty because method 1, which is now on line 16 if you're following along, doesn't take any parameters. But the parentheses still have to be there. So if we run this, all we're going to see at the console is hi. Nothing else fancy that we have to do with method 1. It just does something for us. Again, you could rename it something more descriptive like do hi or do greeting, and then maybe on this line of code it would read a little more clearly. But again, to keep these lined up with the 4 cells in the table, I want to call them method 1, method 2, method 3, method 4. So method 2 is a little bit different. If I just call method 2, that's not an error. It's not a bad line of code. It just doesn't do anything. It is the equivalent of just typing there. Oh. It's the same thing as if you had just typed a string and thought that it would be a complete statement that did something. A string isn't a complete statement that does anything. It's just a piece of text. It's just a piece of data. So you call method 2, all we have on that line is it's just like you had typed a piece of data there. It doesn't do anything. To do something with that, we've got to capture that result, utilize that result, employ that result in some manner. What I did in the Keynote is just use system out print ln method 2. So if I run that now, we should see hi there, which is, I need a space in there or something. So we'll need to play around with that a little bit. But you can see the word there is now at the console. Another way to handle methods that return values is to create a variable that gets the result of the method. So as an example, I could create a string variable that captured the result of calling method 2. Let me zoom in. Sorry, I forgot to zoom in. Which I'm now doing on line 11. So I say string data equals method 2. Method 2 runs, it returns the word there, and then I can use the variable data to make use of that result. All right, method 3 is a void method, but it takes a parameter. So notice when I just type in method 3, or if you're doing it on your own, there's an error. So let's hover over it and see what the error is. It says the method 3 string for the type in the type SimpleOneOfEachDemo is not applicable for the arguments parentheses. So it isn't the clearest error, but you see it has something to do with the method, and you see it's actually showing you that the method needs a string parameter. But it's essentially saying this requires a string parameter, but you've passed it empty strings. So we need a string in there. So if you're following along, I'm going to put my name, but you should probably put your name. That would make more sense, or your pirate nickname, or whatever it is. So let's run it, and this should say, hi there, John. Still not perfectly formatted. We're going to need to add a new line in there somewhere. That's method 3. And then finally, method 4 is a non-void method. It returns a string, and it takes 2 parameters. So, right off the bat, if we just type method 4, that's not going to work. The error will be because we haven't sent it the parameters. In the Keynote, the two strings I sent it were arg and exclamation point. That makes the error go away because now the method is getting its 2 parameters. That's what it needed, that's what it has, which it's not going to do anything because method 4 returns a value that we're not using. So it's just like writing arg on that line of code. So to actually make use of it, we need to pull it into a variable, we need to use it or use it in an expression, in another expression of some sort. I'm going to do the system out println example. So all I've done is now made use of the result of the method for call. And if we run it, we should get something like this. So it's still not perfect. We need some new lines in there. And then it's sort of up to you. Do you want to put the new lines inside of the methods? Like, should high always be on its own line? If so, we could add a new line right there. I'm on line 23, which will push the there to after the high. Although that doesn't really look good. I think what it needs more than anything is just a space. If I was building a report out of these sort of variables and method calls, I add formatting in the line itself. But you could go in and change the method and have it return space there or something like that. That's how methods are called. Let me make one other change. Maybe you forgot exactly what method for did, and you want to say arg, but you just send it arg because that's what you want it to say, and then you'll notice that there's an error. So the error is, if we hover over it, going to be very similar. It's going to say the method for string comma string and the type SimpleOneOfEachDemo is not applicable for the argument string. So what it's saying is the method needs 2 strings. You've only sent it 1 string. So when you declare a method and say that it needs 2 parameters, when you call it, you have to give it those 2 parameters. So again, that's slightly different than other languages. In the mobile apps class in Lua, the parameters were optional. You could declare a function which took a variable, a parameter, and then not pass it the parameter, at which point the function would just proceed with a nil value that you could handle inside the body of the function. Java doesn't do that. Java is going to enforce that you send it the parameters that you declared that it needed when you wrote the method. If you want a version of method for that takes 1 parameter, you'll need to write that as a separate variation of method for. Again, these are sort of contrived examples that don't really do anything of any particular use. So I wanted to create an example, pirate example, and that use methods extensively to give you a nicer example. Maybe if you wanted to go back to a slightly more complex program and look at, you think I needed an example of a method that does something like this. I remember he did something like that in, for instance, DoubloonMethods. You can come back and look at DoubloonMethods. I think it's simple enough you'll be able to understand it easily, and it gives you multiple examples of each of the method types all in one place. So what does the app do? The app is called DoubloonMethods, or it's the pirate membership level analysis app. So again, the running example in the book is that we have this horrible pirate pizzeria restaurant, Captain Jack Parrot's Pirate Pizzeria. It has a membership club in which customers can earn doubloons and then achieve a membership level. And then the membership level will let them take advantage of certain features of our store, like perhaps free napkins or a chair, stuff like that you would otherwise have to pay for. And so, but the basic idea is this app is sort of simulating a database lookup where it says what is the membership level for each of our customers. It looks up their balance and then uses logic to declare that they're a gold, silver, bronze. There's some lower levels as well. There is no metal to represent how little you mean to us, which is fairly low. And then the lowest level is you're like dirt, but not quite as good as dirt. So that's all the app does. And then it also calculates the average and displays it. So it's a kind of an old school report generation app. It does not actually look anything up in a database. It just generates the balances randomly, which you'll see when you peek in the code. So there's examples in the code of each and every one of these types of methods. So there are examples of methods that take parameters. So the example here in the customer report generator is there's a method called addSummaryData, and it takes an array of integers, which is the data for each customer's doubloon balance. So when you call addSummaryData, when you see addSummaryData called in the code, when we switch back to that, you'll see I always pass it this array so that it can do its work. It's a void method, which means it doesn't return a result. Instead, what it does is just display it, calculates the average, and then prints it out to the end of the report. And so look for that. When we switch over the code, look for these. A no parameter example is getBalance. So when we call getBalance, it takes no parameters, but it does return an integer. So it's a get method now, a little an appropriately named method. It's meant to simulate looking up a value in a database. All it does is generate a random number and return it. So getBalance returns an integer number, which is the number of points or doubloons or whatever. I flip-flop back and forth between calling the membership club points and doubloons. Whatever it is, it's an integer in this case. So look for getBalance. In terms of notes, you have to, if you declared the method to take parameters, you have to pass it the parameters in Java, and the parameters you pass have to match the data type that you specified. Java will use automatic promotion to help you out if it can, but in general, you want to avoid doing that. And if you ask for a double number, for instance, you want to pass it a double number, and so on. And the order has to match. Whatever the order is laid out in the method signature, you have to follow that. And we already looked at what happens if parameters are invalid. If you violate these rules, you'll get a compiler error or perhaps just a really odd results from your app. All right, and then the void methods don't return anything. They just do something. So I've got a method in there to look for called drawLine, and all it does is draw one of these lines. So for instance, here in the screenshots, you can see, hey, I'm using a row of hyphens and a row of equal signs to create these line effects in my report. The method that does that is drawLine. DrawLine takes one parameter, which is a style, an integer, and that's that number. When you look at the code, it'll make sense. The style number drives, do I get a line made out of hyphens or equal signs or something else? So when we call drawLine, it doesn't return anything. It is in and of itself a statement, a valid statement. So you just say something like drawLine style 1, and that'll draw the hyphen line or the equal sign line or whichever style 1 is. No need to capture any result or use it in an expression of any sort. All right, and then returning results for a method that takes no parameters. getBalance is the example of that. Returns an integer value. That does have to be captured. So when you call getBalance, you need to do something with the balance that you get. You get an integer, and then you have to feed it into an expression that does something with an integer. So the example on this shows you maybe you're going to put it into an integer variable called bal that will store that balance temporarily while you build up the line of code in the report. Here's actually, without having to peek into the actual code, this is actually the getBalance method, which we've looked at in terms of what it does and what you have to do with it to call it. It's meant to simulate looking something up in a database without any of that complexity. So all it does is generate a random number. Yeah, so a note about entering these sorts of methods. If you're typing in one of these methods and you give it a return value like we just did, let me go back to, if you were typing in this getBalance method and you typed int getBalance, open parenthesis, close parenthesis, open curly brace, and hit return, you would get an empty method without any lines of code in it if you were typing that, say, in Eclipse, but you would immediately get an error, which is a little bit frustrating because you're going to say, well, but I haven't typed a line of code in the method yet. How could there be an error? The error is because you haven't typed a line of code yet, and it needs at least one line of code, which is a return statement that returns a type of data matching the data type of the method. So in this case, it has to return an integer of some sort. Until you write that return statement, that method will be underlined in red as an error. So if that bugs you tremendously, occasionally when I'm typing them, I'll just return temporarily a value that will make the error go away. So I'll put, for instance, return -1 as the last statement in the method, and that'll make the error go away, and then I hope that I'll remember when I get finished writing the method to remove that sort of placeholder return and put in its place the correct return. Let's switch over to Eclipse, and again, this is in your download, and in fact, like some of these others, I might have made some changes here to make points when I was teaching it last, so I'll be on the lookout for any inconsistencies, and hopefully whatever you download is the original version. But let's run it. So it starts out blank, you press the button, so that simulates again that it's looked up data in a database and done some sort of math on it, and it's produced this very valuable report, which indicates that our pirate customers are not doing all that well. There's a lot of silvers and bronzes, and then kernel size is well, not doing well, at least for this report period, so that's too bad. and then it calculates the average and displays it. So nothing fancy. It is random, so if I keep pressing run report, I'll get different reports every time. Let's look at the code. So this app is called DoubloonMethods. From a UI standpoint, it's pretty simple. It's a JText area inside of a JScroll pane and a JButton. And the JScroll pane is added to the center region of the JFrame, and the button is added to the south region, and that's the interface. In terms of data that I use, I've set up 2 arrays. So I've got an array called customer name string, which is an array of strings in which I've got Captain Kidd, Mr. Beard, Captain She, Miss Bonnie, and Sir Morgan, and Colonel Sy, I think at the end, yeah. And then I've got doubloon balances here on line 30. This is an array of integers, and it's empty, it's just declared. So it's declared to be an array of integers, and it's sized to match the number of names that are in customer name string. So that way if I add or remove pirates, my customer doubloon array also is sized correctly no matter what changes I make. This is not a great way to organize this data, let me just say as an aside. Because what if I get the balances out of order? What if I don't keep the doubloon balances synced to the names? There's no clear way to know, for instance, if you just look at the customer doubloon array and dumped it out to the console, there's no way easily for me to look at it and know that, for instance, hey, that 27, that belongs to Blackbeard. I won't know that because the doubloons are just integers. There's definitely a better way to do this. So this is one of these cases where I'm going to say, kind of like bad money round, you know, where I told you this is one way to round. People typically try first. It's not a good way to round, so I refer to it always as bad money round. This is sort of like, I don't know, bad data management. It's not bad, it works, and lots of programs have been written using techniques like this, certainly. But it's risky, and it's not really as easy to use as it could be. When we hit chapter 10, and more specifically when we get, I think maybe chapter 13 has got the array lists in it, we'll figure out a better way to manage this data. But I'll tell you, spoiler alert, if you don't want to know, the way we're going to do it is we're going to create a customer class. The customer class will describe our customers, including their names, their addresses, their doubloon balances, whatever other data we might want to collect about them. And then we'll fill an array list with customer objects. We'll only have then one data structure, which is the array list of customers, and each customer will be fully described by their object. It'll be super, super easy to use, and the code that we write, once we've got it set up that way, will be clearer than the code in here. Anyway, that's a spoiler. If you had your ears covered, you may uncover them. Okay, so then the methods. I've put a little guide to the method numbers again. There's the 4 types. 1 and 3 are void, 2 and 4 are non-void. 1 and 2 have no parameters taken, 3 and 4 have parameters taken. So then I've got a bunch of methods. Again, the order that these are listed is irrelevant, but I've got an example of every different type of method that we're talking about, and I identify it with the number and brief explanation here. But so let's look at the code real quick and just see if you have any questions. The main method does the stuff that we normally do, which is this is a windowed application, so it extends JFrame, we give it a size, we set up exit on close, we set it visible. In the constructor, I set up the UI, and again, all it is the scroll pane in the center region and the button in the south region. And then I've got these essentially utility methods that I declared to allow me to make this app more easily. So drawLine, all drawLine does is append hyphens, a row of hyphens, to the text area. Normally I would end that with a /n, but just to give you one more method, I created a method called EOL, which returns the underlying character. Just to give you one more example, here it is on 75, 76, 77. All it does is return /n, so nothing fancy. But drawLine is a type 1 method. It takes no parameters and it returns no data. It just does something. But I have a second drawLine here, and that's maybe something that'll throw you. Because you might look at that and say, well, wait a minute, you already defined the drawLine method. How can you create another method that has the same name? Why is that not an error? Is it an error? It should be an error. It's not an error. It's not an error because A, the app works, and B, you're looking at it in the compiler and there's no underline. So it's not an error. It is okay to create as many methods as you want with the same identifier as long as you give them unique parameter lists. This technique is called overloading. And so in this case, the first drawLine takes no parameters on line 58, 59, 60. And the second drawLine on line 64 through 72 takes an integer style parameter. So when we call drawLine in our code, Java doesn't have any difficulty knowing which of these to run because it looks at the parameter. If I pass it a parameter, an integer parameter, it runs the second drawLine. If I call drawLine and don't pass a parameter, it runs the first drawLine. There's not really any chance of confusion. And just as an example, because occasionally people ask me, wait a minute, you said you can't declare a method inside of a method. And it looks like here, maybe on line 66, what are you doing? You've got drawLine there. Didn't you say you can't do that? So I'm not declaring anything on line 66. I'm calling. On line 66, I'm calling the drawLine method on line 58. So that'll jump the flow of execution up to line 59 and execute line 59, which is to draw the original line, which I've declared now to be style 1. So it's not a declaration, it's a call, it's a method call, it's a method invocation. You can call methods within methods. You can't declare a method within a method, but you can absolutely call methods within methods. And in fact, everything we're doing here is calling methods. DrawLine's a method, append is a method, and here append is a method as well. So it is really common to use methods inside of other methods. The restriction is I cannot declare a method within a method. So what does that mean? Let me do some of this typing, which sometimes screws me up next semester. But if I decided here, I need another drawLine method that uses some other symbol. So I'm going to say it's a void method. It's drawLine. And I'm going to say it's going to take a string parameter. Because I'll make the line out of that string maybe. And then I'm going to say, ta.append s. So I'd have to put that in a loop to actually create a line out of those, which would be fine. But even as a first step here, you see all this red. So let's hover over it and see. I know that's really small on your screen, but it says void is an invalid type for the variable drawLine. That is not a helpful error message. But the clue that it's really confused is here, at the word variable. It thinks you're creating something called drawLine as a variable. But clearly the parentheses are there. So according to what we said, Java should see that as a method. But essentially, Eclipse is saying, well, it can't be a method because you're inside of a method. There's no way, it cannot be a method according to Java's own rules, so it must be a variable, so the programmer must be trying to do something with a variable. They can't possibly think that they can declare a method in there because you can't. And yet that's what we're doing. That's why that's an error, and that error message is not super helpful. If we just take that and move it, I'm going to cut it, and I'm going to paste it right there. Now you see that exact same code, I haven't changed a character in there. I just moved it. I moved it outside of the second drawLine method that takes the style parameter, the integer parameter. And I just moved it outside so that it is now outside of the body of any method, but inside of the body of the class. All the errors went away. That's a perfectly good method. All right, it's a little bit of a tangent that's not on the Keynote, but hopefully that's helpful. A slightly more complex method is addSummaryData. It takes customer doubloons as an array of integers, and then it creates this little report this little summary at the bottom of the report, which says summary data, and then it displays the average balance. It gets the average balance by calling the method getAverageBalance and passing it the customer doubloons parameter that it got. GetAverageBalance is right here, conveniently. It's always nice if methods that use other methods are declared close to each other in your code so that you can, if at all possible, see them just by scrolling up and down, a short amount. But anyway, getAverageBalance takes the array, the integer array, and then loops through it using a for loop, adding together everybody's balance and then returning a bad money rounded version of the average. And again, a bad money round is another example of a method here. To give you one more example, instead of using currency format to do it, which doesn't use a method. And I should actually say, this app is written to give you as many examples of methods as I thought I could cram into a small example. They are not necessarily great methods, and bad money round is kind of the flagship bad method. I mean, it works fine as a method, but it's a bad way to round money. The examples here are mainly to give you examples of working methods of all these different types in a context where you can see them working together to do something slightly more complex than just saying, hi there, John Arg. The membership level uses if-then logic to figure out what membership level, what your status is. And then actionPerformed is actually what does the report generation. So when the button is pressed, actionPerformed runs. I fill up customer doubloons with their balances using a loop. So I loop through the pirate names array and fill up customer doubloons with doubloon balances. And then I just build up this output. I draw a line, I append customer lists, I append this kind of odd looking bit of text here where it says pound.name : /t balance /t membership level. So to make sense of that, you need to know that the /t, which I've highlighted here, is the escape character for tab. So that will create a tab in the output. So if we run this again now, maybe you'll see that the stuff seems to be lined up unusually well, maybe. The balances are all lined up, the names are all lined up, membership levels all lined up. So that's done via strategically placing these tabs in the text output. So if you're going to produce a text report of some kind, you certainly want to format it and make it as readable as possible, and the tab character can help you do some of that. Then I use a second loop just to display each pirate along with their balance, along with their membership level. And I do that using this long string concatenation and also by accessing data in both of the arrays. So J+1 is the customer number. Let me see if I can get these both on screen at once, and that'll make more sense maybe. So you see for each customer, there's a number. That's the J+1. There's a period, which is right there. There's the customer's name, which I look up in the customer name array. So Captain Kidd is the first one. And then I append on a tab, and then their balance, which is in customer doubloons, that same index number. So Captain Kidd has 34 doubloons. I type the word doubloon, but then you'll notice some of it should be plural doubloons and some of it should be singular. Again, just for making it nice and readable. So I add the S if it's necessary, which is just to say, if customer doubloons is 1, then I don't append anything. Otherwise, if it's more than 1, I append an S onto doubloons. Then a tab, and then the membership level, which is the method we just looked at with the if statements that told you if you're gold, silver, bronze, dirt, and so on. That's how we get each of these lines of the report. And then I draw a line and add the summary data, which is, in this case, average balance 15. So this is it's not a huge program. It's pretty straightforward to understand what it's doing, and it uses as many methods as I could cram in there so that if you're looking for an example to go back and look at of methods used in kind of context that makes sense rather than something completely contrived, you could come back here and look and get an idea. So you should see we're on access modifiers, which is the slide I wanted to get to for today. So I'm going to leave you hanging, but I wanted to tease you. We will talk about access modifiers, but not yet. So you'll need to wait until Thursday to learn about access modifiers, obviously, unless you want to read the slide and or finish reading the chapter out and get a handle on them before Thursday. I know there's a lot of syntax, and there is a kind of a common reluctance among beginning programmers to write methods. It initially seems like it might just be easier to copy and paste. I mean, copy and paste is pretty easy. And I know a lot of programmers start out thinking, I'm not going to bother. I don't want to have to look up the syntax. I don't want to have to think through, do I need parameters or not? Why don't I just cut and paste? I already have this code working, so why not just cut and paste it? And I would just say, in the long run, even not the long run, the medium run, using methods is far easier than cutting and pasting code over and over. So it's definitely a skill you want to master and become really comfortable with. And I try to use methods a lot throughout the semester to give you lots of examples and help you think through why I usually talk through why I'm creating the method and what it's doing and what its role is, hoping that you get comfortable with it as quickly as possible. If there are no questions, that's the end of my coverage for today. We'll pick up on Thursday at Action.